Hi friends, welcome back. Now let us look at what the transfer learning is all about. Transfer learning is a machine learning technique where a model trained on one task is reused as the starting point for a different but some related task. Now how does this matter? A machine is trained for a particular task. So for a human, it is a particular task, but for a machine, when it comes, it's all numbers. Input is a number, output is a number. So for example, if we have defined or designed a machine learning model that is to distinguish between various categories of flowers, then we have trained this model using multiple images, many images of various categories of flowers, and each category consisting of many images and all that. And if this is done by a big organization, then it has got a lot of resources, so thousands of systems it can make run parallelly, and with all that, thousands of machines working in parallelly, learning to differentiate between the various categories of the flowers. It might have taken some months to train with billions of images and all that. So for a big organization, having a big setup may not be a big issue. Collecting billions of images also may not be an issue, and running all the algorithm in parallel may not be a big issue. Waiting for months together may not be a big issue, and all with all that they have created one model, and this model accepts various flower images and finally tells what category of the flower it belongs to. Good. But what actually is happening is the image of the flower is only a flower when it is viewed by the human on a screen. But in reality, when you say an image is just a file. A file is made up of some tensor, a set of numbers in 2D if it is a monochrome image or gray image, or 3D if it is a color image, or 4D if it is a video, and so on. So whatever it is, it's just a tensor, a group of numbers, and this group of numbers is fed in and said that this group of numbers means it is a rose, this group of numbers means it is a lily, like that it was trained. Done. So we have that model available, and thanks to today's open source way of working, so nobody wants to keep their secrets with them, they want to share with the whole world, and because of this open source culture, the model which was trained with billions of flower images is made available openly through open source. Say I try to use this model and start giving uh, images of the, say, animals. Yeah, again it is flower or animal is under the context of human vision. When human views that image or that data as image on the screen, then the human identifies whether the object is a dog or a flower and all that. But for a model, it's just a tensor of numbers, whether it is a flower image or a dog image or a cat image or an elephant image, whatever it is. So at the end, what the machine is doing is taking a tensor of numbers and giving an output in the form of, again, numbers. And let us try using a model that was trained for flowers and try to give images of animals. Let us see what could happen. So dog and cat and all that are just our version, but at the end what goes into machine is again set of numbers, a tensor of numbers. Done. A tensor of numbers, say for a dog we have given in, and the machine looking at those numbers may think that it is rows, says rows. Show another dog, if it feels that it is rows, it will say rows. So that way, keep on showing dog, and if it keeps on saying rows consistently, then what we can do is just change the label. Instead of rows, put a label of dog. So that's as simple as that. So what we can do is reusability. So today's mantra is reusability. You don't have to create everything from scratch. Whatever is available, try to use it. And if I want to use it, I don't have that big network, I don't have that big facility, I don't have that huge number of inputs and all that to train. Even I don't have that infrastructure that I can complete training process in month. If I try to work with my machine, then whatever happened with the big infrastructure in months, it may take more than lifetime and all that. So that's not physically possible. But yes, they made it possible through open source. So their model is made available to us, and if I want to use that and give my input to that, then if it starts some consistent output, like for every time dog is shown it says Rose, every time cat is shown it says Lily, like that, if it happens consistently, then I can just change the labels and use the model without any problem. That is the concept of transfer learning. So reuse a model from where we stopped, start from there. So just fine tune the model. So instead of training the whole model, so we usually talk about model as a neural network having layers, or tens of layers, fifties of layers, hundreds of layers, sometimes more than hundreds of layers are there. So when you're talking of hundreds of layers of neural network, then billions of or millions of weights are there which are to be adjusted during training process, and that's what takes large amount of time. And somebody has already done this exercise and that model is created, that means all the weights are available. But if it is not perfectly matching with what we wanted, what we can do is the last layer, keep it open, all other layers just freeze the weights as it was earlier, just modify last layer, just fine tune the last layer weights. So with the simple fine tuning, if we can get our work done, that's it. So that is the concept of transfer learning. So here, instead of training a model from the scratch, we transfer knowledge from already trained model. That's what we was talking. So a model was able to identify the flowers. Now the same thing, if I can use for animals, nothing more than that. That is the concept of transfer learning. So think of it as using what you already know in one subject to help you to learn another one. So that way you can think of. So what is the need for transfer learning? It saves lot of time. So training deep models from scratch take huge data and too much of computing power. As I said, if this is done by a bigger company like Google or Meta and all that, so they have big infrastructure with them, they have big workforce, they have so much that they can collect huge data, they can have a lot of computing facilities, so they can use months together to train it. But that's not possible for every individual. So make use of that instead of starting from scratch. Make use of that available model. So that's going to save a lot of time. So if you want to know in absolute sense, then what actual training from scratch could be done in years. If that is available, then the same model retraining or fine tuning it may take few seconds or few minutes to solve the problem. So much of time saving we have because of this, what we call transfer learning. Accuracy, yes, definitely. They have used billions of images for training. They have used a big platform for training and all that. Lot of time they have invested on training, and definitely we have built a wonderful model. Just a minor fine tuning can solve our problem. Therefore, the best possible accuracy is possible through transfer learning instead of starting everything from scratch. It is almost next to impossible to get anything in real time, and that too with the best possible accuracy. And definitely when it is we doing it, the data set we have will be usually limited in size, and if we try to train any model, then it is not possible, and then therefore our model will not be properly built, and hence our uh, whole work goes waste, because it doesn't make much sense because of small data set available, training and all that will not be efficient. So best would be transfer learning. How does it work? So pre-train a model on a large data set, just like I just said. So like an example, ImageNet with millions of images is created. So we do have something like ImageNet, ResNet and all that. So pre-trained models are available, and thanks to open source culture, they are available for free usage. Anybody can use it. And what else? What else you require? Just use them. Transfer the learned features, edges, shapes, patterns to a new task, whatever you are talking about. Just transfer these new learned features to a new task and get the work done. So for getting it perfectly done, so fine tune only some few last layers to fit to the target problem. So we have talking about a data having thousands of categories, and with 1,000 categories data a model was made available. Now we are not going to work with 1,000 category data, so we may have data with 10 category data, and I can just fine tune the last layer. Instead of having 1,000 outputs, I can just convert to only 10 outputs, and only the last layer weights I can modify while training, and that way fine tune it and get the target problem to be solved. So for example, deep learning model trained of billions of general images like dog, cars, trees are available. So we can build a model for detecting pneumonia from the X-ray images. So yes, so we have a model which is trying to identify objects of general thing like dogs, cars, trees, streets, animals and all that. But nowhere our data set was having X-ray images or CT scan images or any such thing. Then if we start giving these X-ray images and all that, and if it somewhere solves our problem accidentally, because at the end, whether you talk about image of animal, dog or anything, or talk about image of X-ray, what goes in is just a tensor of numbers. A tensor goes in, tensor comes out, and that tensor may be anything. It's only the human who is going to decide what it is. The meaning of the tensor, it is only the context based. If the images human thinks are of the having objects like cats, dogs and all that, then it is cats, dogs. If the human thinks that this is an X-ray for pneumonia or something like bone fracture or something, then it is about that. If human thinks that it is a CT scan for brain tumor identification, and okay, that is that. But at the end, what goes into the model is a tensor. What comes out of model is a tensor. And what you name it, what names you give for input, what names you give for output is all human based, and that just labeling, change of label solves the whole problem. So that's a way we can use the model used for detecting dogs, trees, cars, etc. to identify whether the chest X-ray image contains any symptoms of pneumonia or so. So instead of starting from scratch, we can take a pre-trained model like ResNet, VGG, fine-tune it with medical images. So that's what we are talking about. So now we have already this ResNet or VGG models are available. So take that, just change the last one layer, keep it trainable, rest all thing, freeze the weights, then start giving the images of chest x-rays and say this has pneumonia, this doesn't has pneumonia, this has a pneumonia, this doesn't have pneumonia. So train that, only the last layer gets adjusted. With the least efforts, with minimum training time, we can get the best result out of it. So that is the power of transfer learning. So with the transfer learning using such models, we can get a high accuracy with less data and minimum training time. So application of transfer learning, computer vision, so image classification, object detection, medical imaging, we name anything in computer vision. The best way to do is use transfer learning. Many models are available on the open source under Keras, under TensorFlow. Many models are available. Just make use of them. Just fine tune according to your problem, get your problem solved. Natural language processing, yes, another important thing, because today our laziness is not allowing us to type anything. At the end, I want to just instruct to my machine that there are images there, just look at that and tell me what image contains and all that. So I just want to talk to my machine as if I am talking to a learned human and all that, and ask my computer to solve my problem. So there comes the natural language processing. So these all transfer learning can be very much helpful there. So one model is available, then make use for any other. Speech recognition is another thing. So adapting general speech models to specific accents, domains, etc. Because when you are trying to train, so every 50 kilometer you travel, the way people speak changes, the languages change, the way people speak change, even though it is called the same language, name of the language is same, you just say English only, but every 50 kilometer you travel across any place, the way each word is pronounced, the way the sentences are formed are so typical that you can't just make anything universally possible. So need more intelligent way of doing that. So instead of starting anything from scratch, if any such thing is available, then just make fine tuning that if it is working for say British accent, then how those words are pronounced in America. If you just connect them, then now your machine is now ready to accept the American accent and all that. Same way, any other thing. So makes our life quite simple because of transfer learning. So at the end, let me look at a few applications of whatever we have learned here in the machine learning. It's the best way to work with healthcare, like the disease prediction, drug discovery, and all that. Because the mainly we are talking about the programming and all that. So we want to create a software, and those who are creating software are definitely don't have any domain knowledge about healthcare and all that. So it is not possible to understand the whole domain and then create a code for that. Instead of that, we can just try to copy their behavior through machine learning, and that way lot of development is done now in healthcare and all that through machine learning, and because of that so much of advancements are possible. Under finance, fraud detection, stock price predictions and all, yeah, even the experts sometimes fail to identify frauds. Even experts fail to identify when to purchase a share, when to sell a share and all that. But through machine learning, we can make it more accurate predictions and all that. Transportations like self-driving cars, traffic predictions and all that. So that's today's era is about the self-driving cars, and even about the traffic prediction. Google Maps already giving that. So if you say where to where you want to go, it tries to look at all the possible paths and looks at the traffic and all that, and then suggests the best path for you to travel from one end to other end. And that is possible only through machine learning, otherwise it was just impossible. So under the retail, you have product recommendation or a movie recommendation, a song recommendation, talk about any recommendation system used by Amazon, Netflix, and all that is only possible because of the machine learning. We can't predict the human behavior and all that, but we can dump all the input available about the human's past behavior onto the machine and ask it to learn the behavior of a human and then suggest what would be the next move of that human and all that, what product that person may want to buy today, or what movie a person wants to see today. So that's all depends on the mood, past, and all that. Just looking at that, we can recommend it. Natural language, yeah, chatbots, language translation, everything is possible only because of machine learning. So that's it for now. Thank you very much. If you have any queries, please do write to me, given my mail ID. And all these videos and many more videos are available on my YouTube channel. So please do visit my YouTube channel for more videos, more information about other similar topics. So that's it for now. Thank you. Bye.